Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering the Module 4 Inquiry Question 1, the 2018 QATs 11Physics paper, Question 29. We have two positive charges, 8 microcoulombs, 4 microcoulombs, separated by a distance of 50 centimeters. It says, draw lines on the diagram to represent the electric field strength pattern between the two charges. Because they're two positive charges, they are going to repel each other. Okay, so we draw sort of like an isotope line. Obviously you can draw them a bit closer, but just that kind of gives you a hint of the idea. And then we draw that. Now the thing we know with the 8 coulombs, because it's twice the amount of charge, we should draw twice the amount of field lines, or at least the field line should have double the density. So something like that. Next thing you need to draw is the direction of the electric field. So we know it always goes from positive to negative. So the arrows should be leaving our positive charge here. One of the recommendations I would make is just put maybe a positive value for the charges, so you recognize the difference of charges you're dealing with here. So that kind of goes through question 1 already. And then next question says, calculate the magnitude and direction of the electrostatic force between the two charges. Okay, so we have these two here. The formula we're going to be using is F equals to 1 on 4 pi epsilon naught times Q1, Q2, and then R squared. Okay, so epsilon naught here is a constant, and that is 8.854 times 10 to the power negative 12. All these other ones you can actually just work out from the diagram that we have. So Q1, we can say it's the 8 coulombs, microcoulombs. Now microcoulombs is 10 to the power 6 coulombs, which means Q2 can be the 4 microcoulombs that we have here. And then in terms of distance and separation, that's 50 centimeters. So this is going to be 50 10 to the power minus 2 meters. Okay, so substitute the values into the equation. And then once you've done that, plug it into your calculator and look at what value you get overall. Okay, let's plug it in. Okay, so the overall force we get is 1.150 newtons, and it is repulsion because we have two similar charged particles, or two like charged particles, and when we have two like charged particles we get repulsion, which is also why at the top here we drew the lines as not meeting up. Okay, so hopefully this explains to you a bit better of how to use Coulomb's law and drawing electrostatic forces and electric field lines. Thank you for watching, give it a like for support, and see you next time.